the schedule. Yeah. How many minutes? Because we are really over time. 5 minutes. Хорошо. 5 минут. Да. Спасибо огромное.
Thank you. Before starting my speech, I wanted to thank Timur and Lana and all the team of this conference for helping me get in here. I also want to thank the Beninese government who made this possible by giving me an official passport. My name is Sounouvou. I come from a small country called Benin in Africa, near Nigeria. And I believe that technology is natural. It's natural, and technology can become very bad because of the human emotions. And it's good to think that we must stop technology, but it's better to think that what to control is the human emotion. The global emotion is what drives science to become good or bad. And it's our responsibility as scientists to work on controlling that global emotion. I want to start my speech mentioning something that everybody here and in the world is feeling. A worldwide epidemic, the stress. The stress is caused by excess of work, and also because the scientists have not invented enough technology to help the human being get out of this. 66% of American adults suffer from stress-induced chronic health condition. And it's the same thing everywhere in the world. People die in Japan because of overwork. But how can we as scientists work to solve that problem? How to launch highly adaptive robots to help the human being in our everyday lives. It has been a question that all the scientists have been thinking about for many years. How to maintain the complete control of an adaptive robot and prevent from the science fiction horror scenarios that we have been seeing in many movies. How to accelerate the learning process of bionic intelligences. How to create an artificial brain factory, and how to ensure that robots won't replace human beings in our works. Those are the questions that many scientific teams are focusing on. And I've been focusing on those questions also for 5 years now. And I think that I found a solution. And I'm here to present you that solution that I call the flying humanoid robots. Why the flying humanoid robots? In fact, robots today, as we are advancing in creating humanoid robots, the looming risk is that robots can start replacing human beings, and many people will lose their jobs. Many people are already losing their job because of technology. But how to preserve those people's jobs by creating robots? That's why I've been thinking about small-scale robots. But before talking about these human robots that I think can be intelligent enough to assist human beings in everyday lives, and that will be flying, I would like to present you how I think this can work. To make this technology happen, I've been making many researches about the work going on in the world, and I've been a lot inspired by Dr. Kevin Warwick's from Reading University's experiments by using neuronal liquid on electrodes to control robots. This proves that the neuronal liquid can control robots. And from that postulate, I've been imagining that we can create brain factories. By creating those brain factories, we can be able to control exactly what the robots learn. Today, we think many scientists are creating robots that can learn for themselves. But the risk is that robots can learn good things or bad things. But how to be sure that we control that? Sorry, I'm coming. To control that, I've been thinking about an equation. The equation does not appear in the PowerPoint, but it's an equation that make us sure that we can control by a scientific panel when robots all over the world will be learning an action. We'll be able to decide whether the action is good or not, and allow this robot to act or not to act. But how also to launch this factory? By learning the neural teaching process, I've been writing an equation. We react to three types of stimulus most of the time: to images with our eyes, to sounds, and to our feelings, the other senses. And we act through these three types of stimuluses. And the result is that we analyze those stimulus and we go to reaction. We have two types of reaction. We can talk, we can make a speech or make a movement. And electrically, by applying the equation, we can be able to put it in those brain factories. And also to make the robot intelligent enough, I've been writing an equation to understand life. Life generally equal to energy plus intelligence plus muscles. When we have muscles, in religion they talk about soul, spirit, and body. But when we have these three factors, we are sure that we can make something live. So for our robot, we already, by those systems, by the brain factor, we can have those intelligent robots, and by those equations, we can control how the learning process. But how are we going to launch those robots? I've been making many researches about 3D printers, and I made many schematics about how to use 3D printers to create faster robots. And with 3D printers, we can create those robots. One of the questions that we'll be asking ourselves is, how are these robots going to look like? These robots will be humanoids, but we'll have the capability, thanks to the 3D printers, to make them look like who we want. We can have application in music and have our preferred stars face on the robot, or even our own face. We can have many applications on the morphology of the robot. And to make these robots fly, I've been thinking about a technology that can make them fly. And I created a system that I call the high compression flying system that can be also applied to a car. You can see on the PowerPoint a model of flying car you can see down a model of flying car they have made through this technology. So this robot can be able to fly thanks to this high compression flying system, and there won't need any wing or any rotor on the top. The application of this technology can be numerous. In space exploration, it can be useful because today humanity tends to go to the moon and go back, tends to go to Mars and go back. But thanks to that technology, we can send those robots that they can use the material resources of those planets and create those robots on those planets, and we can create. Sorry, I'm a French speaker, so I'm searching my words in English. We can go from planet to planet without being obliged to move ourselves from the Earth. We can control, thanks to the internet of space, those robots on the other planet. They can reproduce themselves and go colonize the universe. They can accelerate. For transportation, the high compression flying system can be used for our cars, but also for larger use for planes also. For energy, there is something interesting. A Beninese, from the country where I come from, someone invented a free energy generator that we are going to use for this robot and for the cars. And that technology is totally autonomous. Maybe who is interested can Google and see what I'm talking about. For education, this robot we can have specialized education according to every people. For example, you can ask your robot an explanation about the world. The robot can Google the word in his mind and tell you what it is exactly. For healthcare, you have an application, and down you can see the healthcare robot. They can be watching sick people in hospitals. And for advertising also, you can have a robot. They will find a robot that can see you on the road and talk to you about a project of something. There are many applications possible. You can also use them for our children who can have small robots as toys. I'm finishing my speech with that. I'm just a theorist. I'm an autodidact. I'm a computer scientist from Benin, and my goal is to continue the researches with other teams who may be interested with my works. Thank you for listening, and bye-bye.
Yeah. Thank you, Rita. Believe us, we really appreciate both your speech and your attempts to come here not being the bionic robot.